Okay, so here we have a decision problem. There are two options, bet on bet one or bet on bet two. A marble is going to be drawn from a jar, and the marble will be either red or blue. And then these are the four possible outcomes. Okay, so this material that I'm going to go over is on pages 22 and 23 in chapter 2. And so we'll start with what's on page 22. Let me read this. I will use the expression XPY to mean the agent prefers X to Y, and XIY to mean the agent is indifferent between X and Y. Okay, so given these four outcomes, let's say that for me, this can be different for you, but for me, I prefer the trip to Rome over the iPad Pro. And we can also write that as Rome P iPad. Okay, the next. I am indifferent between the iPad Pro and the $800, which we can also write as okay, iPad I $800. I'm different between the two, or we can just write it in the opposite way. It doesn't matter for being indifferent. Okay, and like most people, I prefer $800 to $60, which we can also write that way. Okay, so that's not all of my preferences, but that's some of them. Now, let's look at this. Decision theorists have proposed a minimal set of conditions that the preferences of an ideally rational agent must satisfy. I will refer to these conditions collectively as the ordering condition, and then the 8 components of the ordering condition are O1 through O8 on the next page. We might also call each of these a condition if we want to. Okay, so let's just see how these work. So we'll take the first one. If some agent prefers X to Y, so X and Y are the two outcomes or the two alternatives that we're considering. So if someone prefers outcome X to outcome Y, then they don't prefer Y to X. So for me, I prefer Rome to the iPad, getting the trip to Rome to getting the iPad. And so for me, it's not the case that I prefer the iPad to the trip to Rome. Okay, and then the second condition, if an agent prefers X to Y, then that agent is not indifferent between X and Y. So again, I prefer the trip to Rome to the iPad Pro. And so therefore, I'm not indifferent between them. Okay, so if you're thinking this is just common sense, that's fine. That's the idea. These are the conditions that when we're rational, and that's not to say that we're always rational, but when we are, we're following these conditions. Okay, the third condition, if I'm indifferent, or if some agent is indifferent between X and Y, then that person does not prefer X to Y and does not prefer Y to X. So let's see. I said I was indifferent between the iPad and getting $800. All right, then condition 4 tells us the next condition requires that any two outcomes be connected to each other via the agent's preferences. So that is, there has to be a relationship between every two alternatives that we have. It has to be the case that for every agent, X is preferred to Y, or Y is preferred to X, or the agent is indifferent between X and Y. Okay, so okay, so it has to be the case either that I prefer Rome to $60, or I prefer getting $60 to going to Rome, or I'm indifferent between the two. Again, in other words, there has to be some relationship between any two alternatives, and it has to be one of these three relationships. Okay, now you might be able to guess which of these three is true for me, but I didn't state what it was up here when I initially laid out these three. So let's use, let's see, the fifth and the seventh conditions to figure it out. So according to condition 7, if someone prefers X to Y and that person is indifferent between Y and Z, then that person will prefer X to Z. So again, the person is indifferent between X and Y, and then Y and Z are equivalent. So that means that the person also is going to be prefer X to Z. Okay, so these were both given in my initial list. I prefer Rome to getting the iPad. And I'm indifferent between getting the iPad and $800. So therefore, if I have this preference, Rome is preferred to the iPad, and then these two I'm indifferent between, it has to be the case that Rome is preferred, the free trip to Rome. I prefer the free trip to Rome over getting the $800. Okay, then condition 5. If an agent prefers X to Y and also prefers Y to Z, then that agent will prefer X to Z. Okay, so we just said that I prefer the free trip to Rome to getting $800. And up here, I also said that I prefer $800 to $60, getting $800. Oops. To getting $60. Therefore, it has to be the case that I prefer Rome to getting the $60. Okay, so we've shown that this one has to be the correct one. Okay, let's just do one more. Condition 6. So if an agent prefers X to Y and is indifferent between X and Z, then that agent will prefer Z to Y. Okay, so the agent prefers X to Y, X and Z are equivalent, so therefore the agent will prefer Z to Y. So for me, that means because I prefer 800 to 60, and I'm indifferent between the $800, getting the $800 and getting the iPad. So therefore, I prefer, or it has to be the case that I prefer the iPad to the $60. Okay, so that's all of them except for this last one. If an agent is indifferent between X and Y and also indifferent between Y and Z, then the agent will be indifferent between X and Z.